Alright, so for this one, the best move to start is to draw a circle. And then from there, we're going to draw a chord on this circle. That chord is going to be 12 inches long according to the problem. And the midpoint of that is going to be 8 inches from the center of the circle. Now, that's not a radius, but it's on its way to being one, right? It's not quite to the edge of the circle. However, if we go from the center to either of the endpoints of this chord, that is a radius. Get that there we go. So now we can see we have this triangle formed, right? But before we jump to that, we need to know that the two parts of this blue line that are on either side of the orange line, the two parts of the chord, are being cut in half, because we know that from the center to that midpoint is going to be, because it's to the midpoint, it is cutting that perfectly in half. So that means that each side of that orange line is 6 inches. So now we have a right triangle with one leg, that's 8, one leg, that's 6, let me draw that a little bit more to scale, and then a hypotenuse, that's our radius. And we know it's a right angle too because of the bisecting chords theorem. So that's the first theorem we've used. So now we have this triangle that we need to find our radius for, or the hypotenuse of the triangle, which is the radius of the circle. It's a right triangle where we have 2 out of 3 sides, so we are going to use Pythagorean theorem as well. So we have the 2 theorems we're going to use. Now we need to actually do the calculation. So our radius squared is going to be equal to 6 squared plus our 8 squared. So our radius squared is equal to 6 squared is 36. 8 squared is 64. When you add those up, r squared is going to be equal to 100. And now we just need to square root both sides. When we square root both sides, we're going to eliminate the square on the left. And we're left with our radius being equal to 10 inches. So there we have the radius for our clock. So up next, we're going to see another theorem. The intersecting chords theorem. This one states that if 2 chords intersect in a circle, then the products of the lengths of the chord segments are equal. Chord segments are just the parts of the chord that are on either side of the other chord. So in this case, AB times BC is going to be equal to DB times BE. That's true no matter what angles they're forming in that circle. So let's take a look at an example with that. Try this next problem.